All right, hello, konnichiwa. We're going to talk to you about building command line applications for everyone. I am not Yehuda.
I am not Godfrey.
But we are members of the Ruby order, and we are here to bring you mruby. 私のザックリー・スコットと言います。ここで Twitter のアカウントをフォローしてください。あとでザックの日本のアカウントある。ここをフォローしてください。僕はバマント州というところ生まれた。でもバマントくらいしてるの。でもバマント州でバマントくらい作られない。シャットフライという会社で働いています。ここでオープンソースとレガシーコードを仕事しています。よろしくお願いします。
Hi, I'm Terence. I go by Hone02 on Twitter. I wear blue hats. I work at Heroku running the Ruby experience, so when you push Ruby apps to the platform, that is the stuff that I work on. I come from Austin, Texas, where we have pretty good barbecue and some amazing tacos. And I'm also one of the co-founders of the Ruby karaoke movement in the last few years. And we're actually doing some Ruby karaoke tonight. So if you want to sign up and you haven't already, go to the RubyKaigi events page and you can find the link there and sign up. So I hope to see you all there. Today we're going to be talking about building CLI applications in Ruby, and that's broken up into 3 parts. The first part we'll be talking about kind of the history of packaging in Ruby and why mruby is a really good fit at solving that problem, and then the work that Zzak and I have done to make that a really good experience. So to start off, let's take a look at the packaging landscape in Ruby. And I think the Heroku toolbelt is a really good story to kind of walk through the steps of like where that's been and where it's going. So when we first started like 6-7 years ago, Heroku was a Ruby gem. So we primarily had Ruby customers, which made it a really good fit because it was a native experience that I think any Rubyist was really familiar with. And it meant that as a company, we didn't actually have to solve any of the packaging and distribution problems. You just had a gem install Heroku. But as we kind of targeted other kind of customers, like if you were a Python developer, it kind of sucked to have to install Ruby just to use Heroku. And if you're any other service provider, that would be the same too. And even if you were a Rubyist, it really was not great for the maintainers of the gem because it meant that we couldn't guarantee the versions that people were running on their machines, which meant that we could never use newer features of Ruby because we always had to support kind of the oldest and made sure there was always compatible. So we were always stuck on 187, which was not a good place to be. So then we decided to solve that problem with the introduction of the Heroku toolbelt. And with this, we took the Heroku Ruby gem and basically bundled it with a statically compiled Ruby runtime as one package. And we built that for every target platform we wanted to support. But it was kind of a huge pain in the butt. We had to have we had a special like Mac Mini to compile the OS X version. We had a special Windows machine that did that. And releasing was much, much harder than just running a rake release on a Ruby gem. And because of all these packaging problems, we started looking at some other technologies. So there was a coworker of mine at the time that started looking at rewriting the whole experience in Go. And one of the reasons was that the performance of running just booting it. So in this example, we have Heroku version, which all it does is actually just print out the version of the Heroku toolbelt you're running. And in C Ruby, it took about 1.8 seconds at the time when he first started working on this. And in Go, it took 16 milliseconds. So a huge speed difference there. And as we know, like requiring Ruby files at runtime is slow, and we had to do a bunch of hacks to actually get this time down, so that's not what it is today. And the other thing that Go really brought to the table was this cross-compiling toolchain that allowed us from a single machine to not have to have all these different boxes and compile OS X, Linux, and Windows binaries from the same host machine, which meant that we could distribute a single file to all of our customers, which was really great. And Heroku isn't unique in this story. There's companies like HashiCorp that have a bunch of different open source tools. So Vagrant, I'm sure you've heard of Vagrant or Terraform or something like that. They first started in Ruby. Vagrant's still written in Ruby, but all their future stuff is actually being written in Go because of this.
So a while ago, there was another project called Shoes, unrelated to the Heroku tool belt. But this project was designed to build desktop applications for Windows, Mac, and Linux using the GTK bindings and native bindings on the operating systems. It was a huge project undertaken like years ago, and it was all written basically in C, and it was terribly hard to maintain. So recently, the team behind Shoes now has rewritten it in JRuby because it was so hard to maintain all that C code. And this was written in a blog post by the now maintainer of the project, saying that it was really hard to maintain the C code, and mostly because packaging, sadly, was mostly broken. And this is just another case where Ruby just didn't quite fit the bill, or at least MRI. And more recently, there's another project called Traveling Ruby, which was built by the guys behind Fusion Passenger. And what basically they did was similar to what the tool belt was doing, was they package up a precompiled Ruby runtime, all of your application code, and any third-party extensions as well. The problem with this is that the third-party extensions have to be precompiled for each platform that you're trying to support. They supported the same three, obviously, but the problem with this was when there's like a security fix or something, like these binaries are maintained by them, and obviously they have other things going on. So this wasn't a great solution for the community, right? And there's no real great story here that can solve this problem. So one thing we want to avoid is, we want to make things in Ruby, and we want to make that possible. And we don't want Ruby to be the technical limitation, the packaging of MRI to be the limitation behind why we can't build these kinds of applications. And so we have a way now, and we're going to talk to you about why mruby can solve this problem and how it's possible.
So the pitch here is with mruby, we have a smaller embeddable Ruby that is similar to languages like Lua that's meant to have a low memory footprint. But that means since it's supposed to be embedded in other things, we don't have operating system level things like file or socket or threads or things like that. But it does mean that we're able to have a really small core which fits really well for building command line applications. And even though we don't have those OS level things, we still have things like procs and blocks. You can still monkey patch stuff. And then you have literals like array literals and hash literals, which makes it feel like Ruby. So even at the end of the day, there aren't as many things as the standard library in C Ruby. It's still Ruby that you're writing. And people have actually taken mruby and used it out in production in the wild. So one of the examples is there's a project called Nginx mruby, which allows you to extend Nginx writing mruby code. And we actually deployed at Heroku in the last few weeks. We have this Ember project called Dashboard when you log into the Heroku website to manage your apps. And it is running on top of Nginx using Nginx Ruby. So this is our biggest web property, and we're running mruby in production today.
Another place that mruby has been being used recently is in IoT. As far as you can even put Ruby in pizza, I have no idea. But the reason why they're actually trying to do this is instead of using something like C, because one of the goals is that they have to keep the application small, and there's resource constraints when you're talking about embedding in small devices. And so this is still possible with mruby because you can basically pick and choose the parts of Ruby that you want, and it's still really small, but you can still write things in Ruby, and that's the reason why they chose it. And one such example in the real world is a project called OpenWRT, which is designed to embed mruby in routers for internet access. And so you can see in this screenshot, this is the product. They're actually setting up mruby here and letting the user go through and select which binaries they want compiled and the gems they want compiled into the library. And this is all possible with mruby and with the MRB gems build system. And so we're going to talk about a little bit about what's behind that now.
Even though the core is small, with something like mruby gems, we can still have access to a large amount of libraries and pull them in, so you're not necessarily writing everything from scratch. And so at the heart of this, there's this mrubgem.rake file that you have in any mruby application. And it should look similar to if you've ever written a Ruby gem, to a Ruby gem specification file. And then we basically have these dependencies that you can add, which are mruby gems. And there's really 3 sources that you can pull this from. So the first one is core, and that is the mruby gems folder. There's common extensions and libraries that you can add that's built into mruby itself, but not bundled in by default. So you can choose to add stuff that you need there. And then there's this mgem source, and this is probably the closest thing we have currently today to like rubygems.org. And it's basically a list of mruby gems that are been published publicly that people can pull from to use. So there's common stuff like if you need to do YAML parsing or JSON. HTTP request is probably the equivalent to like NetHTTP for doing any network calls there. There's IO, which is, even though like operating system stuff isn't there, you can still pull this stuff in with like mruby IO. And of course, regular expression stuff is there too. And then finally, you can also either fork projects or do other things, but you can use GitHub directly or a Git link, and then pull libraries in that way, even if it's not published on mgem. So for example, we forked the mruby YAML project at the time while we were waiting for this pull request to get merged. We wanted to basically be able to statically compile libyaml into our project and still build it locally.
Yeah, so I want to talk a little bit about what's behind this underneath. And so in order to understand that, we kind of have to dig in a little bit. But yesterday we saw a talk from Koichi Sasada, who was saying that, is this on? He was saying that he's trying to add a bytecode ahead of time compiler to MRI, but using mruby, we've already beat him to the punch. Ahead of time compilation just basically means we can compile the Ruby code. If you miss this talk, it means we can compile the Ruby code into bytecode binary format so that it can be embedded. And this is a feature of mruby. So I'll show you what that looks like. If we use the mruby-cli program that's bundled with mruby, we can output the source of this hello.rb file into binary format, and you can see that there, and we can actually reinterpret that file using the mruby interpreter, just passing the -b binary format flag. So we can take this even further using the mruby-cli program. We can actually generate embeddable binary bytecode, and we can embed that into a C program, which we could then compile. And it would look like, it might work like something like this. We would have GCC we're using here, and then we just include the mruby headers. And we have to link libmruby in order to get access to our code. So this is really the core of mruby's power right here, is all of the gems and all the code that we wrote is available inside of this library. So we can statically link it, and then it's very portable, and we can do whatever we want with this binary. When we're done compiling, mruby basically prints out a summary, and you can see all the gems that were included there and the binaries that were output. There are some limitations to this system because mruby is designed to be embedded and kept small. There's certain regulations on the VM and stuff, and as Terence mentioned, like with gems and stuff, we can't leverage Ruby gems. All the existing gems that are out there have to be basically ported over. A lot of the extensions don't work because the C API is completely different. We tried porting some of the existing gems because we're trying to write command line applications. We started spiking on op parse, and turns out to be kind of a challenge, and most of that is because some of the libraries that op parse uses aren't available yet in mruby, so then we have to work on those, and some of the testing framework is completely different. So we couldn't exactly iterate on it very quickly. As well, since we're cross-compiling for various targets, the ecosystem has to also support those targets, and so the native extensions have to consider this as well when generating code. So recently, one example, we added 2 flags to the build system of mruby so that we could specify the target and host for cross-compiling. And we needed this for the regular expression extension, that we patched this downstream so that we could cross-compile the native extension for Windows. And you can see here, it was actually disabled for cross builds. He didn't even want to support it, but we had to work around this issue so we could get regular expressions working on Windows. And all of this is done really with a lot of configuration and hacks and stuff, and so we want to have a good user experience for building these kinds of applications, so we created an mruby-cli project to kind of tie this together, and Terence is going to talk about the design behind mruby-cli.
Since we're both Rubyists and we're talking to Rubyists, one of the huge design goals behind this was that we want to be, if you're building a CLI application, you should be writing mostly Ruby code. And so mruby-cli is an mruby-cli application in and of itself, and this is the folder hierarchy of it, not including the tests. But as you can see, it's a folder filled with a bunch of Ruby files. And it should look similar to like any other Ruby application that you're writing. The next part is that we saw like in the HK story at Heroku for rewriting stuff in Go was that performance is actually a feature people care about, especially when you're talking about command line applications. You want to be able to have like quick interactions with the service that you're using or whatever the CLI is. And what I mean, besides just runtime performance, is actually like startup time, right? Like how fast is it to boot up the VM and get something out there on the screen? So if we look at MRI and write like the simplest case we can, which is like the hello world example, it takes about 41 milliseconds to actually run this. And then when we do this with mruby-cli and we write the same thing, it drops down to 3 milliseconds. So you're talking about an order of magnitude speed difference because of the design choices in mruby itself. And then, so the other compelling thing that I think Go really brought to the table for Heroku was that you could compile a single binary for every major platform that you wanted to support and kind of just hand that off to customers and not have to essentially distribute like a runtime with like all this stuff as multiple files. And in mruby-cli, we wanted to make sure that was possible. So leveraging mruby's build system, we were able to compile stuff for Linux, OS X, and Windows as well. And having a decent file size was also important. So like the JVM, for instance, is fairly large as a VM. So we wanted to make sure that the binary we're producing isn't necessarily super large. So the OS X mruby-cli binary here is only 421K. And like Zach was talking about, we want to essentially build a platform for the ecosystem that people could target for building command line applications. And finally, to actually get adoption to happen, we wanted to make sure setup was as simple as possible to get up and running to actually use this thing. So Zach's going to talk about actually setting up a hello world using mruby-cli.
Yeah, so if we want to create an application using mruby-cli, the first thing we should do is go to the project page on GitHub and then go to the releases. You can see here we've had 4 releases. And underneath is a list of downloads. So these are all packages for each architecture to run mruby-cli. And so since I was using a Mac at the time, I downloaded the x86-64 Apple Darwin package, untarred that, and then put the binary in my path so that you can see here I can output the version of mruby-cli, and it just works. As well, we can print out help. This just looks like any other command line application because it is. And you can also see there's a setup command, and so this is how we generate an application for mruby-cli. And all we have to do is pass the name here. So you can see I've created a hello world app, and this is very reminiscent of like Rails new, right? Except I'm not DHH. But you can see a list of files that get created, and basically, I'm going to go over like each kind of file and what they're meant for, and so that you can start building your application. And so the first file is the build config file, and this is really how we orchestrate the mruby compiler to do all the things we need. And we have a bunch of different targets in here. And the first target is to run on the native Linux hosts. We'll get to like the host environment in a second. But the native host, we just use CLang to just basically adopt the system. And then we have 64-bit and 32-bit Linux binary configuration. As well, we have 64-bit and 32-bit OS X binary configuration, and same for Windows. So all this just gets generated for you, and this is actually just telling Ruby itself, which is used to compile mruby, how to do that. And so each configuration target, we have another method we call gemconfig, and what this basically does is tells the compiler to include this gem, which is just your application packaged up as a gem, and it's just in the local path. So this looks like Ruby code because it's literally being run by MRI and not mruby at compile time. And so if we look at the gem specification for the app, it looks very similar to the one we showed you earlier. We add dependencies, this gets generated for you, and so we have mtest and print, and I'll get into mtest in a second, but basically this is where you put your dependencies, and then the most important option is the bins option, which tells mruby to generate a binary for your application. And basically, we give this file for you. It's the bootstrapper for the command line app, and it's just a C file. You don't have to read it, but it's generated for you under the tools directory. And because we use that bins option, mruby knows to look here and compile this C program for you, which is linked against your app code using libmruby. Basically what this does is initializes mruby VM and then parses the command line arguments and passes those arguments to a global method called main. And so we also generate the skeleton for the main method for you. You could change this implementation, but the method does have to be defined in your code globally, and that's the entry point to your application. Also, we have tests because we think you probably want to iterate on tests. And so we generate two kinds of tests for you. The first one is bin tests and tests. If we look at the test folder file that we give you, you can see that it looks basically like a unit test. And that's because it is. It's using the mtest library, which is created by IIJ and a Japanese company. And it's basically designed to test your code inside of the mruby interpreter. So it's running inside of mruby. The other test we give you is bin tests. And this is actually more of an integration test. If we look at the implementation, we can see it's actually shelling out to Ruby to execute this file. And so you can use all the things in Ruby that you love to write tests with, and for integration anyways, and including like popen and all that stuff, and you don't have to worry about any of that stuff. It's just right there on the container for you. So how do we use this? We also give you a rake file. This is very tiny, so Yehuda can't read it. You shouldn't worry about it. It does give you a bunch of tasks, very useful tasks for compiling mruby and running your tests and stuff, but you shouldn't run it directly. It's actually designed to be run inside of a container, and we give you these two files, Dockerfile and dockercompose.yaml, that are designed to run your application. And Terence is going to talk to you about the workflow of building your application now that you've generated it.
So now that we actually have like the application generated on the disk locally, at the heart of all this is we're using Docker to kind of simplify the support and maintenance of all this stuff. So we basically can standardize behind building stuff on Linux and cross-compiling to all the platforms that we care about. And so like the rake file, we have a dockercompose.yaml that basically transcribes all the rake tasks that we care about into stuff that we can run inside the Docker containers. And then we also, the second file being the Docker file, and we basically inherit from an image that we've been working on, so you don't have to build or kind of figure all that stuff out on your own. So all the Docker stuff lives on a GitHub repo that's publicly available. And inside of it, we basically install all the dependencies that you need to get up and running, so you don't have to set any of this stuff up to get all this cross-compiling support. So we do GCC for both 32 and 64-bit Linux and the headers that we need there. The min-GW stuff for Windows to get 64 and 32-bit compilers. We have Ruby too to both build mruby itself, because the mruby build system, as we've been talking about, uses Ruby, as well as running the bin tests there. And then finally, we also set up the OS X cross-compiler for you. So you get all that just from using the Docker image. And so then the first command you want to run after that is docker compose run compile. That is not, here we go. And so this is running the compile task at 8x speed, but basically it's mounting your local volume and running it inside the Docker container, and it's building the libmruby.a that zzak was talking about for all the targets, and then you get that build summary there. And then, so this is a screenshot that you see of basically the summary for one of the targets that we've seen a few times. And you can see the binaries and kind of all the included gems that are part of that. And then, so we have the host that we've been talking about that kind of builds all this stuff, as well as the 6 binaries for 32, 64-bit Linux, OS X, and Windows here. And then, so once you actually have the binaries, you can basically, inside the mruby build folder, you can find the binary that corresponds to the operating system that you're running locally on your machine and just execute that binary, and you should see hello world there. And then, once you actually have it compiling, you can now run tests against it. So docker compose run tests will actually run both the integration and unit tests. And then we can actually run the unit test, integration test separately, depending on your development workflow and how you're iterating through this project. But with all those commands, you should actually be able to now iterate through and build, compile, and add new code, and kind of just work on the CLI app that you're working on. And then once you're actually happy with the stuff you've done, you can just take the stuff in that mruby build directory and publish it somewhere, or however you want to distribute your binary, whether it's deployed to server, or in our case for mruby-cli, we're just publishing it on the releases page on GitHub.
So with that, we now have a platform for building command line applications using mruby, as you can see. We realize we're not the first people to do this, and I'm sure all this technology has existed before we tried it, but we are the first ones to really make a target to build these kinds of applications in mruby. And we're excited to share it, and we still have a lot of work to do, but there are some people using it.
So one of the first really neat use cases that I've seen is for the JRuby launcher project. So if you aren't familiar, JRuby is Ruby built on top of the JVM, and the JVM is probably not known for its very fast startup time. So in order to actually launch JRuby, they have these bat for Windows and shell scripts to basically run them. And it's probably not very ideal to have two kind of separate code bases that basically do the same thing minus a few differences for the platform. And in light of that, they've started this JRuby launcher project, which is basically taking that functionality and writing it in C++. And I think Charlie and Tom told me it's taken, like a lot of the code was taken from the NetBeans project in 1996. And as you can see, the main JRuby C++ file, this is a fairly recent screenshot, has not been touched in 6 years. So you can imagine how great that is to deal with. And if we take a look at the head, like if we run head on that file, we see the last copyright is from 2010 from a company that doesn't even exist anymore. And even though there's been commits and stuff since then, it hasn't even been released since over a year, like last November or sometime. But we're excited to see that a friend of mine, Joe Kuttner, has been basically trying to replace this JRuby project since the summer using mruby-cli. And hopefully with things going on target, we should be able to replace JRuby Launcher with this project sometime next year.
Another project we've been made aware of is called Archon, which was created by Ryunosuke Matsumoto, who also made the Nginx mruby project. And so he's using mruby-cli to basically command his Linux servers. I can't really say much about the gem, but after like only a week and a half, 2 weeks, it already has over 300 stars on GitHub and was mentioned by a rather reputable Linux system administration blog, which has almost 50,000 followers. So it's really exciting to see some adoption and people making stuff that gets noticed and getting it out there. But we're not done. We still have some work to do. We have some things on our mind, and one such thing I really want to work on is the build system. I want to make that experience better and be able to make it more flexible and maintainable, and so we're working to make that that process better.
And the next thing that I want to do is make the mruby ecosystem a good place to build command line applications. And I think one of the things that Rails did really well was to have this platform that did that, but also it basically had a curated set of gems that was built in that worked. So we want to basically do that same thing for CLI apps. And so we're starting with option parsing. So we're building an mruby docop thing to kind of tackle that, and we're going to go through and basically have a set of gems that come bundled in that cross-compile, work on Windows, work on OS X, and work on Linux.
Yeah, so that's pretty much it. We would really like it if everyone would try this project, install it, get Docker set up if you haven't already, generate your first application, and make something. And once you do, let us know what you make, tweet at us. We'd love to hear what you have. Let's build things in Ruby. Thank you.
はい、一つぐらいはできますので、ちょっと時間がありますから、誰か質問がありますか？今はないかな。では考えて、you have a question? Go ahead.
When you're running test suite, does it have to rebuild the VM each time?
No, so as soon as you change a file, it'll recompile all those things.
Okay.
Yep.
では本当にどうもありがとうございました。終わりました。
ありがとうございました。